PCG is awesome in generating landscapes, populating props, and many other things. But did you know you can also use it for game mechanics? For example, here is just a simple floor grid that I can just change the path on. Now, that's not very exciting. What is interesting, though, is the fact that this path uses only one static mesh, but still changes the colors. But not only that, if I was to play onto it, and I hopped on the path and I try to get off of it, I would be teleported all the way back. No matter where I go and try to get off the path, I can't. But if I go all the way through the path, all the way to the very end here, and I get off at the correct location, I can actually get off the path. And now I'm good. Now, of course, if I get back on, I'm fine. But if I get on the path again and then get off, once again, I'm teleported back. And because this is procedural, I can change the path to just be a linear line here. And now, for example, I can go along the path this way. And again, if I go off, I'm teleported back. So let me show you guys how to create all this. I'll set it up and show you a few new cool PCG features that you might have not seen before. Let's get right into it. To get started, I'm going to go to Edit Plugins, and then make sure that the PCG plugin is enabled by turning on Procedural Content Generation Framework and restarting your engine as needed. But once we have that, we really need just a few things, starting with a simple blueprint class actor that's going to house our blueprint for the PCG graph. I'll call it BP Path. I'm also going to need a PCG graph, so I'll go to PCG, grab select PCG graph. This is going to be PCG Path, and we're also going to grab a material that I'm going to call M Path. Those are the three components that we're going to need for this. Let's start with the blueprint path. If you open it up, you want to add yourself a PCG component. And in the detail panel, you want to enter the graph you just made, the PCG path. And also, I'm going to add a box collision here. Now, you can use this as a volume. You can also set it up to use a spline and do an interior. This is all open to however you'd like to do it. In my case, I will just be using a create grid node to make a simple basic grid, but if you wanted to, you could absolutely use a volume or a spline, but just keep in mind you need some kind of volume if you ever want to generate it during runtime. That's why I'm adding it here now to make it easy for myself in case I do want to do it later on. But this has collision, so I'm going to go into the detail panels, search for collision, and set no collision on everything. And now we're good with this blueprint path. So already I can take our BP path, drag it out, and put it just right in the middle of the level. That seems like a good place. And now let's open up our PCG path. To get started, I'm going to right click and search for create grid or create points grid. I'm going to set the grid extents to be 2500 by 2500 by 50. And I want the cell size to be 500 by 500. And we can leave the height at 100. If I press D on this, you can see we have our grid here. But if I was to move this over, it stays where it was. It does not move with the object. So if I change the coordinate space to local component, and then I debug it, you could see, well, it's moving with the object, but what is all this? And honestly, I don't know why it's showing a second copy at origin, but we know we can ignore it because I can just use a static mesh spawner after this and add ourselves just a simple mesh entry of any kind, like a sphere. And you'll see it is only spawning it where I actually placed it, not in any other location. So we can just go ahead and just use this and ignore the original points that it was showing when you were debugging it. So great, we have our create points grid. So now I want to do a path from one point to another because we want the path that we're going to take. So what I'm going to do is just add a new item to the scene, just a simple cube. And in the cube, I'm going to search for tag. I'm going to give it an actor tag. And this is going to be our start. And I'm going to duplicate it. And I'm going to give the other cube the tag end. So we have a start and end cube. Now, which one's which doesn't really matter. So I'll go ahead and take one of them and we'll put it over here and take the first one and put it around here. We can move them around, but this is good enough for now because we can make use of the pathfinding node. Pathfinding node, as I've covered before, creates a path from one point to another. Now in this pathfinding node, I want to make the start as an input and I want the end as an input. So that way I can specify exactly where I want things. And the inputs, because they're from the world, I'm going to right click, get actor data. The actor filter will be all world actors by tag, start, and the mode will be get single point. And I am going to uncheck track actors only within bounds. We're not dealing with a bounds here, and it allows me to just put the points wherever I'd like, even all the way out here if we just want to go a little bit outside the range of all of this grid that we're generating. So I'll duplicate it also and change the tag on the second one to end. And then I'll plug the start into the start and the end into the goal. I'll press D on the pathfinding to sample it. And you'll see, well, we have the path. Now, the path is just basic cubes. It is not the points that we had originally, but that is already a good place to start. Now, one thing you can do is change the spline mode here to linear. All that's going to do is make the points become a little more angled, but you'll see some of them are still angling sideways. It doesn't really look like a proper grid. And that's because the pathfinding here is using a search distance of 1000, but I specified the points are within 500. So on the pathfinding node, I'm going to change it to 500 search distance. And then if I have the points outside of the volume entirely and it's further than 500 units away, it won't generate anything. But if I move them a little closer, you'll see, bam, we now have a grid. And if I move the points around, you can see it is generating the grid just like that. Awesome. So this is working. But the one thing I don't like is it's a little bit too just straight and simple. I want it to be a little more interesting. To do that, we can add a little bit of a noise to our pathfinding. So after the creating points grid, I'm going to drag out and search for density noise, which will automatically add an attribute noise set to randomize the density. And that's going to plug into the pathfinding. And now on the pathfinding, we can change the cost function mode from distance to fitness score, and then change the cost attribute to be density. And now if we take a look, you can see it is now no longer just a perfect path to the location. And of course, I can do any other path here. The main thing is we're getting a little bit more interest in our noise. And of course, you can play around with the attribute noise. If I change the seed on this, for example, it'll generate slightly differently every time. So here I am changing the seed, and you can see even though the path is from the same location to the same location, it is changing how it gets there because of the noise. And because it's just an attribute, if you're somehow adding your own information to the points, you can use that information to make the path what you want. Now, I'm not going to go super in depth in pathfinding, but if you are interested in it and you haven't seen my previous video on it, you can check it out right here. And it'll, of course, be linked in the description. But fantastic, we have our path, but we also want to filter the path and not the path separately. Because we don't want to just get rid of the points that are just not the path, we want everything. But we also want to be able to spawn the actual meshes where we need them and to have a different color for this path. So let's get into the material real quick. So over here, I have a very basic material, just a few textures plugged in directly. But what I want to do is change the shade of this base color based on a parameter that I have in PCG. And we can do that relatively easily. If I right click, I can search for per instance custom data. Now there's custom data and custom data 3 vector. Now I'm going to use 3 vector because that way it'll give me red, green, and blue. So we can just completely tint it whatever we'd like. But of course you could absolutely use per instance custom data and specify a different index here in the detailed panel. You can, for example, make it 0 is red, 1 is green, 2 is blue, etc. You can absolutely give it the control you'd like. But for our case, the tint is going to be good. Also, I'll take it, and then I will just do a simple multiply here for the RGB, and that is going to plug into the base color. Now, it immediately turns this ugly color, and that's because the per instance custom data default here is black. So I'll make it white by default and turn the alpha up as well. And you can see we're back to having the normal stuff plus just this custom node. So great, very simple setup here. So now we can start filtering out the different sections. So the first thing I'm going to do is take from our attribute noise, and I'm going to use a difference node, and I'm going to plug this pathfinding into the differences. And on the difference node, I'm going to change the density function from minimum to binary. And now if I debug this, you can see there is our original grid. Now, of course, it's with all our density changes, but you can see now our path is cut out. And to get the opposite, I'm going to use one more difference node. I'll just duplicate the current one. This difference is going to go to the differences of the second one, and the original attribute noise is going to go to the source of this one. And if I debug this one, you can see I now have just the path. So basically what we're doing is cutting out the path for one version, and then the path that has been cut out, I'm using to cut out from the original again, giving us the 2 versions, this one and this one. To help you remember which one's which, you can absolutely add a little comment bubble that just says something like path only and no path. So fantastic. So from here, we can drag out and do a static mesh spawner. It'll add a conversion node. And if we drag both of them into a static mesh spawner, we can add in a simple cube here. I'm using a basic shape cube, but I'm going to add an override material, and I'm going to add the material that we've created. But as you'll quickly see, the cube isn't exactly scaled to what we want. Because we've changed the size of the points, we didn't change the size of the actual thing that is being spawned. So right after this create points grid, before the attribute noise, we just add a transform points node right here. And all it's going to do is scale it by 5. And the reason I'm scaling it by 5 is because we made the create points grid node 500 units. And because the basic cube is 100 units, I know it is 5 times. So I'm scaling it min and max by 5 times. And now you'll see we have a perfect grid. But of course, nothing is darkened yet. To darken it, we'll need a few things. With nothing selected, in the right-hand side, we want to add some parameters. First, we'll add one parameter. It is going to be of a type linear color, and I'm going to rename it to path tint. And the default tint for it will be just pure white with RGB and A all being 1. And we'll do one more, same thing, linear color. And I'll set this one to be something like 0.1 in its value by default. And I'll rename this to non-path tint. Nice and simple. So what I'm going to do is change the color of these points to these colors. So after these differences, and before the static mesh spawner, I'm going to drag out and search for set attribute. And I'm going to right click and search for path tint. And that is going to go into in B here. And it's going to throw an error that says at last from in A does not exist. So what we can do is select the math operation. And of course we don't want last even. So I'm going to hit the plus icon and select color. You can see the color from pin A does not exist if we hover over the error. That's because it's not a point information, so it's not very happy. So what I'm going to do is drag out from the out and plug it back into the static mesh spawner to just get us this conversion node. And I can just plug it in into our set, and you can see it now becomes very happy. And we just need the same information down for the bottom one for the no path version, except we need to grab non-path tint and plug that one in. And now we can plug both of these in. Now it's still not using anything here. If we take a look, right, it's still all the same color. But what we can do is make use of this instance data packer. In the data packer type, which is from none to by attribute, and then you add an attribute selector, and we can just specify color. Because it is already RGB, it is going to work for our use case. And immediately you can take a look, and we now have the main path being lighter than the everything else. And if we select the actual PCG graph, you can see here, it is only using one instance that it's copying around. And if we go to the PCG graph, we can of course override the path tint and make it even darker, for example, to 0.05, and it gets even darker. And if I adjust the exposure, you can see it now gets properly dark. But let's say this is the exposure level you want, and now, you know what? This is nice, but what if we also wanted to be an emissive? We want to just glow. Well, keep in mind that you can absolutely do that. We can just reuse this, or really reuse a per instance custom data node and just use value 0 if you want to use just the red channel, for example, and multiply it by the base color. And we can put that inside of emissive color, and you'll see it is glowing. And if we change the path tint here in the red channel to be 10x, you'll see it is going to glow more. Now it's of course going to tint it as well, but you can see now we have the actual emissive value of it tied to the red channel. So you can customize this quite a lot using this per instance custom data and setting it up in the attribute selectors. So fantastic. We now have this path. It is working. We hit play. It is extremely high up. So we probably want to actually do something about that. And the fact that, well, I can't quite land on it. It has no collisions because I'm in 5.5. By default, nothing has collisions. So let's adjust a few things. In our transform points at the very beginning, I'm going to turn off uniform scale, unlock it, and change the scale min and max here to 1 on the Z axis, which is going to bring it way down, which is a lot better for us. And the other thing I'm going to do is on the static mesh spawner, I'm going to open our mesh entry and scroll down to the collision section, and I'm going to select block all. So now what we can do is just run up to this section, jump on it, and walk on it as a just regular path. But of course, we have no functionality. So how do we get this functionality? Well, we can have PCG spawn that functionality all for us. And we can do that using the post-process functions that PCG provides. I'll hit plus to add a new index there, and I'll give it a name just called path. Now, it's giving me a warning, and that's because path was not found in BP path C, but that's okay. We're about to add all that information. So in BP path, I'm going to add ourselves a new function. This is going to be called path, the exact same name we gave it. And while it's still selected, in the detail panel, I'll make sure call in editor is turned on. And if I go ahead and compile it, you'll see the warning has gone away and we're all good in the PCG graph. So now what is this going to do? What we're basically going to do is spawn box collisions using this function only where we need to, and then track if the player is within any of the box collisions. And if they are, great. But if they're not, put them back where they belong, which is at the beginning of the path. Or of course, wherever you'd like to specify. Now, just so it doesn't regenerate this as I'm working on it, because that could break things, I'm going to do a simple cleanup here. And now when I hit compile, it doesn't just regenerate it, as you can see. So I can work on it without worrying of breaking anything. I can, of course, leave it on, and if something breaks while I'm mid putting in the nodes and I hit compile when I shouldn't, I can, of course, just delete it and put it back into the level, and everything will be fine. But also, as an extra precaution, I'm going to select our PCG node and change the generation trigger. Instead of generate on load, generate on demand. So that way, only I specify when it generates. So now, what do we do on this path? Well, first we need to get the information from our points. I'm going to right click and search for get components by class. And we want to get the plural components, so you get an array output. The component class is an instance static mesh component. And I'm going to drag out and search for get. And we want to get a copy of the first index, which is the only index in our case, so we don't need to go through the entire array. And I'll right click this and promote it to a variable, and I'll just call it ISM comp, which is just short for instance static mesh component. And that is going to go right after path. This is just so I don't have to drag this giant thing around. I can just put it in the simple variable. And if I ever need it anywhere else later on, it is a global variable instead of a local one. So now we need to actually loop on all of the points and actually do something with them. So using the ISM comp, I drag out and then search for get instance count. The instance count starts at 1 instead of 0. So I'm going to drag out of the return value and I'm going to do a subtract 1. And as you might have guessed, we're using a for loop. It's a regular for loop, not a for each loop. And that get instance count -1 goes into the last index. And you plug it in right over here. So I'm going to right click on the index now and promote it to a local variable. And I'll just call this index, because we only need it while in this function. But this is going to go through every single point. I actually want to go over only the points on the path, which means I need a way of filtering out what are those points compared to the others. Now, unfortunately, while we can set the custom data through blueprints, you cannot read the custom data from the material through blueprints. It's unfortunate, so there has to be a workaround. Now, there's two workarounds. One is basically using a separate mesh for both versions. So that way you'll have two things in the detail panel, just two separate cubes, one with one setup, one with the other, and then you can filter it by index. But the thing I like to do in this scenario, because it's all flat, is just offset the transform just a little bit on the path, so that way we can read that information and figure out which is the path nodes. So back on the PCG path, on the path node, all I'm going to do is drag out and search for a transform points node and plug that in before the static mesh spawner. And on this transform points node, I'm going to move the points up ever so slightly. You can see I'm moving it up 4 zeros, 1 after the decimal points. Very slow amount. You're not going to notice this at all, but technically it is above 0. So that means back in the blueprint path, I can use this information. So now what we can do is take our instance static mesh component and then search for get instance transform, and the instance index will be the index that we just set right above. And I'm going to right click on the out instance transform and I'm going to split it, and I'm going to check that the location here is greater than a certain value, but only the z axis, which means we're going to use a break vector and check if z is greater than 0. And if z is greater than 0, then we know this point is a path node. So fantastic. We have now filtered out the path nodes. So fantastic. From here, we can just drag out of the branch true node and search add component by class. And the component we're adding here is a box collision. And from here, I'm going to right click on the relative transform and I'm going to split it. And now what I can do is drag in the location into location, rotation into the rotation, and scale into the scale. But here's the thing. The box collision is not going to be the right size relative to our points, and it's also not going to be in the right location relative to our points. So in my case, because I'm using a 5x multiplier, I'm going to actually scale this by a certain amount. Now, to demonstrate what I mean, I'm going to generate the points right now, which will break things if you do it at this current moment. So don't do it in your setup, but I'm going to do it just to show you. If I go ahead and click generate, you'll see nothing is really here. And in fact, our paths, all our box collisions are right here at origin, as you can see. They're not where the path is. And that is because this checkbox is very important, world space, when we're getting the information about these transforms, we always want to do it in world space. So go ahead and check that on. And now you'll still see nothing. And that's because if I go down into one of these panels, there's our box collision. It is not quite the right size, and it is not quite where I want it to be. So what I'm going to do is from the transform locations, I'm going to drag out and just search for a simple add. And I'm going to add 100 units in height. And that is going to be the new relative transform location. And then for the scale, I'm going to drag out and just search for a simple multiply. And that is going to go into the relative transform scale. And the multiply I'm going to do in my case is 1.57, 1.57, and on the Z, 3x. And when I do that, you can see it is now very visible right above your grid, which is perfect. And if I take this grid and I move it, you will see that, oh boy, it is relative. So the points are not generating where they're supposed to. So how do we fix this part? This is because this is relative transform locations, not world space locations. So from here, what I can do is do a simple subtract and search for get actor location and plug that into the input here. And that is going to go now into the relative location. So we're going to take our relative, we're going to move it up, and then we're going to offset it by how much the actual actor has moved. And now as I move it, you can see it is following it, but it's following it a little bit behind. It's a little lagging there. And that's okay. We will fix that momentarily by making sure that we remove the collisions and then have new ones created each time. So from this add box collision, I'm going to right click, promote to variable, and this is going to be our overlapping components. I'm going to delete this then. And in the variable, I'm going to right click on box collision to make it an array. I'm going to drag it out and just do a simple add array here. And I will add this box collision to this array. Now from here, I of course need to remove it at the beginning. So I can grab our overlapping components and do a simple for each loop. I'll plug this into the execution here. And in the array element, I'll drag out and just do a destroy component. Now, if you're planning to do this both at runtime and manually in editor, I recommend adding a simple is valid check to make sure that it only does it if it's valid. Otherwise, there's a chance you're going to have things in this array that you generated during the editor that are going to be gone when you press play. And this just makes sure that it doesn't do anything with them and doesn't scream at you saying, hey, those don't exist. And now from the completed, we go into the for loop. And now if we drag this around, it is still lagging, but the main thing is if we move the point here, you'll see it is now snapping correctly, and this is all good. And we can adjust both of these, and it lines up each time. I'm going to put mine at the very middle here, where I need it to be, and I'll readjust these points. And you can see, again, the path here is nice and windy thanks to our noise. So that's fantastic. We have these box collisions, but they don't do anything yet, right? We can go in here, we can go around. Nothing has changed. So let's make them actually do something. I'm also going to just quickly select the start and end points here, and I'm going to just search for collision. I'm going to set the collision preset to no collision, and I will make them hidden in game. So that when I hit play, they're no longer here. Okay, well now we have the box collisions. How do we use it? Well, it's actually really simple. We can bind an event on entering it and on exiting it. So I'm going to drag out from the return value, and I'm going to search for bind event on component begin overlap, and that's going to go after this add. And I'm also going to drag out and search for bind event on component end overlap. And that's all going to come from this box collision. But we don't have an event for this. So what we can do is drag out of the event here and search for create event. And I'll do the same thing for the other one, create event. And again, because we now have the option of select a function, we also have the option for create a matching function or create a matching event. I'll go ahead and create a matching event. This is going to be on begin overlap. And I'll do the same thing for the other one, create a matching event on end overlap. Now we don't want to have these in our path function. So I'm going to press Control X to cut these, and I'll paste them right into our event graph. Now that will make the actual binds here break. So I'll just go ahead and just click the drop down one more time, and you'll see on begin overlap and on end overlap here as nice, easy selections. So fantastic. We now have something that it will bind to, and this will be for every single box collision. So now what is the logic that we need to, well, have it so we get teleported only when we exit all of them and not just go from one to the other? Well, it's actually really simple. I'm going to take other actor and I'm going to right click on it and promote it to a variable. And this is going to be our overlapped component. I'm going to, again, delete it, right click on the actor type and make it an array, and then add the actual other actor now to this array that we made. Now I prefer right-clicking and converting to a variable and then converting to an array this way, because then the type is selected automatically for me, and I don't even need to think about it. And now that we have the overlap component added to the array, we can use it and remove it on overlap. So I'm going to grab overlap component, and we don't want to use remove item. The reason we don't want to do remove item is because it removes all instances of the item from the array. And we only want to remove it once. Basically what happens when you do remove item is because it's the player that's constantly in these areas, in these collisions. If he's there twice, it will remove it twice, automatically clearing out whatever's there. So what we can do is use, instead of a remove, we can just drag out of the overlap component and search for find item. And we want to find this other actor, and we find the index, which will most likely be 0 because we're doing it with just a single player. But in case you were to set it up later on with multiple players, this will find you the specific player. And then you could do filters for specific players later on. But once we find it, we can go ahead and just do a remove index here. The index will be the one we find, and that is going to go right here. And then what we could do is just check if it is empty. Because if this array is now empty, then we know that we have left this area. Now, where do we want to put the player? Now, in my case, I want to just put him back on event begin play to where he started. So I'm going to right click and search for get player pawn. And I'm going to drag out, search for get actor location, and then right click on this and promote to a variable. And this is going to be our starting location. And we're going to set that at the very beginning. And now on true, when it is empty, I'm going to right click and search for get player pawn one more time. And this time I'm going to do a set actor location and rotation, because I want to also reset the rotation back to 0, 0, 0, facing forward where he was originally, but now at the new location from the starting location. And a quick note that my box collisions are slightly overlapping. So that way, when he goes from one to the other, it adds it first before he's exited the previous one. And this is important, so I want to make sure I flag that. So with everything in, I can now hit play. And I can still go into this area, but if I go now on the path, I can go along the path, but as soon as I leave it, bam, I'm teleported back. Now that's awesome. We now have their mechanic. But here's the thing. I can actually follow the path all the way to the end here. And technically speaking, I have left the path and so I get teleported back, which we don't want. We want it when we get to the very end there, we do not get teleported. All we're going to do that is just add a simple trigger box to the level. Now, of course, you can have whatever you need. You can have an end section with a blueprint, anything at all. We just need a volume here that's just going to check if we're overlapping this now at the very end. So there we go. It is just overlapping at the very end just a little bit. So that way, when we get off of it, we'll be inside of this. So now back in our blueprint path, I need to add a new variable. This is going to be our end. And the type is going to be a trigger box. And we want it to be an object reference. And we also want to make sure that we click this eye icon so it becomes instance editable. So that way in our actual level, we can select our PCG graph. And you see here under default, you see end with a none in the dropdown. We can use the dropdown to select a trigger box, or we can use this eyedropper to just specify the specific trigger box in case you have multiple and it's hard to tell. So we've selected this now. And now on end overlap, what we need to do is check that it's empty, but it's also not in the final area. So now what we can do is grab our end and then search for is overlapping actor. And the other actor is the player pawn. Is it overlapping the player pawn? And as long as it is not overlapping the player pawn, using a not boolean, and it is empty, then we go ahead and do this branch and teleport us back. So now again, if I hit play, if I go here and get off the path, I get teleported back. But if I go all the way to the path and all the way to the end, just like so, and then get off, you can see I'm completely fine. Of course, I can get back on because there's no actual boundaries here. But as soon as I get on the path again, it'll teleport me back if I get off again. Now, in this scenario, you'll probably want walls around it, so that block off the player from entering this area themselves. But you can see how we've now created a kind of a simple dynamic setup that we can take our end position, take our end cube, scooch it over, and now we have everything we need to pretty much start it wherever we'd like and also end it wherever we'd like, because we just move this over. And you can see, and it all gets updated as normal. So there we go. A fun little mechanic thanks to the power of PCG to automate and make things a little more modular and procedural. If you have any other ideas for fun little mini games to potentially make with PCG, let me know in the comments below. I'd love to hear them. And of course, the project files for this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And of course, the link to the Discord will be down in the description below if you'd like to join our community. And if you're looking for more awesome PCG tutorials, check out this one right over here. That's one of my favorites.